Okay, so we are now moving on to the protein chapter. And to begin with, I would like to emphasize to you that not only are we studying science, but in some regards we're studying history, because history does inform everything, including science. So I'm going to tell you a little bit of a story to kind of help you understand how we've come from some of the things you've heard or that are ingrained in our minds to where we are in reality. So protein was first recognized as a distinct molecule in the 18th century. So keep in mind that means the 1700s, right? And as you look at these visuals, it kind of helps your mind to go back to this point in time to have a better grasp on the period to which I'm referring. So the first time that this structure was described at all was by a chemist in the 19th century. It was actually 1838, so still in the 1800s now in particular. And when he studied it, what he was actually studying were animals, because this was during a point in time in history when studying human bodies was a challenge. And so dead animals, whether it was dogs or cows or pigs from farms, were readily available. And so plants were not something that were yet of interest. We were looking more to learn about human anatomy, and doing so through the study of animals or even human cadavers. So he was looking at animals exclusively, and it's important to keep that in mind because that is in science what we call a confounding factor, a variable that must be factored in and accounted for, otherwise our findings are invalidated. So from a history perspective, if you know what monumental event took place in history from 1914 to 1918, then you can appreciate the fact that we're not talking about very long ago, and yet the world was a very different place at this juncture. So at the point that World War I took place, people within this country were struggling with adequate food supply. Food was still commonly scarce, as it had been throughout most of history. You could see some of these visuals here are a good representation of what was the norm. Most people still lived on farms. Communities weren't as tightly located geographically as they are now. So if you lived somewhere in Alabama, you were eating what was available in Alabama at that time of year. You weren't going to a grocery store where things had been trucked in from other parts of the country, and you were largely responsible for your own food supply. Most people still produce their own food, whether it was through gardens or rearing of livestock, and obviously their success in doing so was dependent upon a number of things, including their own skill level, their available resources, and the weather. And for the most part, people were struggling to get enough food, at least at various points in time throughout the year, if not continuously. So again, we have to consider the fact that all types of foods were commonly insufficient to meet demand. Now, meat in particular required that you have the financial resources to obtain the livestock, and you needed more than one in order to breed something. You also had to have the skill to do so, and you had to have the means by which to care for them, whether that meant the food and shelter to keep the animals going or prevent disease. And so it was a costly endeavor, and not everyone therefore had the ability to raise livestock and therefore to eat meat. Also, to purchase it from somewhere else was going to be very costly. So farming of produce, fruits, vegetables, grains, was going to be much more commonplace for most people, and the consumption of animal foods was going to be the exception at this point in time. Meanwhile, young men across the country were eager to enlist in the military so that they could serve their country in the war. But a trend was observed. Many young men would report wanting to enlist and would be turned away because they were deemed not fit to serve. So at this point in history, roughly 100 years ago, we did understand that something that we now term malnutrition or abnormal nutrition or bad nutrition existed. We didn't fully understand it in its complexity. It has only been probably in the past 50 to 60 years that that depth of understanding has come to fruition. So there was a lot of concern, obviously, about this malnutrition being an obstacle to military enlistment. So this was the impetus for scientists to begin to dig deeper and try to understand what nutrition is all about and what is good nutrition and poor nutrition and how does it affect health. So while all of those with malnutrition that were turned away were lacking in adequate food, period, scientists made a mistake that is common and honed in on a common characteristic shared by these men. They all seem to be from walks of life where access to animals as a food source were limited. In other words, they were not the most affluent individuals, because those people who are more affluent tend to consume more animal products for all of the aforementioned reasons. So those with inadequate food sources were those that were typically going to be consuming a more plant-based diet, and again, variety was probably lacking because they were dependent upon the resources within their own region and largely those which they as individuals were able to produce. So they probably had a fairly limited diet. In other words, from a scientific standpoint, what we would say is that there appeared to be a correlation, a relationship between diets lacking in animal foods and a body suffering from inadequate nourishment. It made sense in time because all we understood was that there was a unique molecule known as protein, and it had been observed in animals, hence animal foods, and then it was therefore reason that an absence of animal foods must mean an absence of protein, and therefore it was deduced that not eating animal foods, whether it was meat or dairy, or eating them very rarely, meant the men were not getting enough protein, and that must be the cause of their malnutrition. So the prevailing theory of this point in time was that animal foods must be the source of protein in food, and thus animal foods must be essential to prevent malnutrition. And everyone was taught we must all consume animal foods. More commonly, it was stated, eat meat, right? And there was all sorts of push throughout communities, throughout the federal government to encourage people to consume meats. And so to this day, many people still erroneously believe that we must eat meat to get protein. It's stuck in a lot of people's heads. You meet many people today who still think, wow, how does that person who doesn't eat meat get enough protein? Or how can you not be eating more animal foods and get enough protein? Well, one thing is certain in science. There is no such thing as a fact. Science simply is designed to study things and determine the most obvious evidence to support the current notion or theory. And therefore, as we continually learn more, as we acquire more evidence, our theories evolve and change. We're constantly studying and learning in the sciences, and as a result, it should be of no surprise that knowledge changes and things that were thought 100 years ago are different today. So remember, in the health sciences, as healthcare practitioners, what you are engaged in when you are doing your job is you are exercising the current evidence-based theory. You are educating people or carrying out tasks that are rooted in what we currently know based on the up-to-date evidence. So we are trained in current evidence-based theory, which means that we practice evidence-based medicine. So let's think things through. Little was known about nutrients in the early 20th century. Protein in particular was still not well understood at all, and the observations that were made failed to take into account all of the relevant details, like the fact that these men were simply not getting enough food of any kind. There was also no scientific study of protein and malnutrition. At this point, people were making assumptions. And a key point to acknowledge is that just because two things appear to have a correlation. Appear to be related doesn't make it so. In fact, in science we say correlation does not equal causation. Just because two things appear to be related does not mean that one caused the other. So later in the 20th century, you can see here from this outline that knowledge gradually began to evolve, and we get all the way to 1949, and at this point, the first protein molecule was sequenced, or as you learned in your textbook this week, we learned that different amino acids bound together to form an entire structure, which once coiled and folded became a functional protein. It wasn't until 1958, so to my earlier point, only about 60 years ago, that scientists came to fully understand protein structures and came to realize such structures exist in all foods. So now we know that all foods from nature have some amount of protein within them. In fact, the only food that has such a negligible amount that it's really not worth acknowledging is fruit. So you would have to eat such a substantial amount of any type of fruit to get a notable amount of protein that we generally, in nutrition terms, say fruit doesn't have protein. And so most often we'll reference the fact that all foods except fruit have protein, though technically even fruits have protein. And that's worth knowing because when we look at allergies at a later point, allergies are a response to proteins. So people can certainly be allergic to certain fruits, right? And that backs up the fact that there are proteins in fruits. So this knowledge is useful in many ways, but for our purposes in terms of malnutrition, we want to focus on the fact that it's easy to get protein pretty much from all foods, though fruit is not really a reliable source. So it is very doable to meet our protein needs without any animal foods, and therefore it is very easy to meet our protein needs with a diet comprised of nominal, even small intakes of animal foods, which is what's recommended by most health authorities, as you've seen thus far, and a wide variety of plant foods, moderation and variety being key once again. So before we look at your book, let me just zero in on a few of the key points addressed there. Hopefully you now have an appreciation of what makes proteins unique. So unlike carbohydrates and fats, proteins contain nitrogen. And literally the word amine in Latin means nitrogen containing. So these structures that contain nitrogen that come together to form proteins are called amino acids, nitrogen containing acids. They are, in other words, the building blocks of protein. So in your text, it explains to you that there is always a backbone to each one of the amino acids, and that backbone is a carbon backbone. Remember, the term carbon refers to the element, and that is an organic element. So when we say that something is carbon-based, we refer to it as organic matter, and life is generally carbon-based. So you will see the carbon backbone with two different ends. Visually, one is an acid group, one is an amine or amino group, the nitrogen-containing part, and each one of these singular amino acids has a unique side chain. And it is the uniqueness of that side chain that is kind of like the recipe for that amino acid. So once a bunch of these amino acids link together, each one of them has a unique side chain. So it's like another contribution to the total recipe. And therefore, cumulatively, those unique side chains are what's going to dictate the function of the completed protein that has formed when all of the amino acids link together. And how do they link together? Well, as you see in your book, peptide bonds are what connect them. So this visual should be a great way for you to bring together what you're reading in the book and to have a greater appreciation for what is being explained there. So once the amino acids link together and they form a chain, the process is not yet complete, right? It is key to understand that they must then coil, much like a ribbon that spirals, and fold. And once all of this takes place, what you have is a completed protein structure like you see here. At this point, it is functional. So we say that the final structure of the protein determines its function. And as you're learning in your textbook, everything in the body, all life-sustaining processes, all bodily functions are driven by proteins, which tell our cells what to do. So in our cells, in the nucleus, we have the DNA, the genetic material, which acts as a blueprint or a set of instructions that dictates both what proteins are made in the body and what functions they will carry out. So you have to remember when we look at genetic diseases that many of those impairments lie in this foundation, in that there was some sort of a flaw in the recipe. When the amino acids linked together, they did so in an odd fashion, such that the final structure did not function in a desirable way, and we get a different outcome. So again, this information isn't relevant just to malnutrition, but also to disease processes that we'll study later. So what you want to appreciate is that the human body is so good at using protein that our needs for dietary protein are relatively small. In fact, we recycle many of the amino acids we take in, and that is, once again, because biologically we are designed for survival, to be very thrifty pieces of machinery, and so we really were not designed for that world of abundance, and therefore we function well when our needs are met minimally. So remember, you learned about the DRI, the dietary reference intakes, and you learned that extensive scientific research has enabled nutrition scientists to develop an understanding of just what sorts of nutrients exist, what they do within the body, and just what amounts a human body actually needs. And if you recall, you learned that the AMDR, the acceptable macronutrient distribution range for protein, is anywhere from 10 to 35% of your total daily calorie needs. So at a minimum, 10% of your total daily calories should be in the form of protein, and you know that protein contains 4 calories per gram, so it is not difficult to calculate those needs manually as a purpose of estimating one's needs. It is important to understand why the nutrition facts panel does not have a percentage. So reflect back to what you learned. You learned that the percentage on each line is the percent of the total DRI for that nutrient. And you were fascinated to learn that one of those nutrients that lacks any sort of dietary recommended intake is protein. And that is because there's no way to generalize that recommendation, since protein needs are so very individualized. It depends upon whether or not you're an infant, toddler, adolescent, or adult, male or female. It depends if you are experiencing a certain stage of life, such as menstruation or pregnancy, or if you are in an elderly phase of life where there is greater lean mass deterioration or cell turnover. It depends whether or not you have any assortment of possible illnesses or any sort of injuries, and it also is dependent upon how physically active you are. So you can see how every person is so incredibly unique. So the range for determining one's needs is anywhere from 0.8, and that's less than a gram, right? 0.8 grams per kilogram to 1.5 grams per kilogram. So we would first have to determine somebody's weight in kilograms, and we can do that very easily by dividing their weight in pounds by 2.2. That gives us their weight in kilograms. And then we would multiply respectively by anywhere from 0.8 to 1.5. So that's going to be the job, once again, as your book emphasizes, of a registered dietitian. Dietitians are going to be trained to know where within that range a person will fall respectively based on being an athlete, having malnutrition or an infection or a digestive disorder, or some side of an injury or illness, as you see here on the screen. Perhaps 1.2 is appropriate for someone, or 1.4 for someone else. So as you do your calculations in the discussion board thread this week, what you're doing is what's visualized here. So for example, if someone weighs 125 pounds, they're going to divide by 2.2. That tells them that they weigh approximately 57 kilograms. They're going to calculate the minimal need, the low end of that range, 0.8 grams. So 57 times 0.8 is 45. In other words, the person needs approximately 45 grams of protein per day to meet his or her needs. And as you look at this example that I've outlined here, with the estimates of what are contained within different foods, you can see how incredibly easy it is for one to meet his or her protein needs with variety and balance, and largely plant-based diet with minimal animal foods as per all of the health guideline recommendations in your book. I'll let you look at this for just a moment, and you can always pause if you wish to look at it in greater detail. But you can see here that this healthy meal plan for a day provides approximately twice of what the person we just calculated requires. So you can see how excess protein is far more likely in today's world than an inadequate intake of protein. It's hard to not get too much. So at this point, I want to go over to your book for a moment, and you should be at the beginning of chapter 4. And as you know, you usually see the learning objectives at the beginning. Hopefully you've skimmed through those. As I click through, you're going to see the Did You Know section, which is what I asked you to put on your assignment. And then many of the key terms are used throughout the assignment, though certainly not all of them. So for any that are new to you, you're going to want to take a moment to mentally process those, since it's likely that you're going to encounter them again throughout the course. It begins with the structure of proteins, which I've just visually outlined for you in the slides, so hopefully that will help you to interpret what you're reading here. We then go into the physiological functions, right? The many different roles of protein. It's not just about muscles. And when we say muscles, incidentally, there are different kinds of muscles, right? Smooth muscles, cardiac muscles, skeletal muscles. So when most people say protein builds muscle, they're referring to skeletal muscles exclusively, and that is but one small role of protein, the macronutrient. Smooth muscles are things like your intestines and your stomach and your lungs, and then of course cardiac muscles are your heart. As you can see here, what I want you to focus in on are things other than muscles of any kind. So be sure you read carefully. Anabolism and catabolism are not new to you. I've referenced them previously, and now the book is going to elaborate, and hopefully you're going to feel like you've clarified your understanding. We get into the topic of nitrogen balance on page 66, and I'm going to leave it to you to read that in depth. I think that it's well explained here in the book. And then remember that synthesis refers to genesis or creation of something. So protein synthesis, how it comes to be, and your body builds proteins. So reflect back on what you already know. You take in whole foods, complex mixtures of all 6 classes of nutrients. Those foods themselves are broken down, and those nutrient constituents are further digested or broken down into their component pieces and parts. In the case of proteins, that means that they are broken down into their respective amino acids. You know that ultimately all of those finite parts are absorbed into your bloodstream through the walls of your intestines and therefore travel to each one of your trillions of cells where they are taken up and used in a reassembly process to create structures that are useful in the body, such as functioning body proteins. It's really important for you to understand what it means to have functioning proteins. So after you look through this very important image on page 67, you're going to get into those different functions. The regulatory role, in other words, regulating body processes. Enzymes, which acts as catalyst on a substrate. Hormones, which are certainly something that we've already touched on and that we will be coming back to repeatedly. Buffers in terms of pH balance and blood pressure. An immune response in terms of antibodies to fight antigens. So you want to make sure that you read carefully and that you feel like you truly understand the material on those pages. On page 69, you see the energy section, and I will verbally tell you that there should be an asterisk there, very important to read. And then you move into protein metabolism. Remember, metabolism is the cellular utilization of the respective substance. So the image here is probably a little bit more complex than what you need at this stage. So I think that the reading, the general concepts is more than enough to help you understand. Again, digestion is outlined, and each different macronutrient is digested differently. Remember, there are 3 macronutrients: carbohydrate, protein, and fat. Each one is a large, complex molecular structure. Therefore, the macronutrients require digestion. Obviously, water, vitamins, and minerals do not. So each macronutrient is going to be digested somewhat differently. As you already know, the digestion of carbohydrate begins in the mouth, and it finishes up in the small intestine. Protein is unique, and that digestion primarily occurs in the stomach, thanks to the actions of our stomach muscles, that mechanical digestion, and the hydrochloric acid and the related enzymes present in the stomach, such as pepsin. When you move over into the section here, protein from food sources, it speaks briefly about high and low quality proteins and helps to clarify that for those of us in well-developed countries with a diet with variety, it is rarely a concern, even for people who don't consume animal products. And so there were some old school diet trends that talked about, oh, you have to eat this with this to get this, when in reality it's not magical within the moment. 2 foods don't have to be combined in the moment. It's within the greater scheme of things. So if you consume a variety of foods throughout the day, ultimately you're going to get all the pieces and parts that you need to assemble the larger proteins that are required. There is a section here I will ask that you read on protein and satiety. And if the word satiety or satiation is new to you, when you are eating and you begin to quote unquote feel full, you are experiencing satiation, right? And so satiety really refers to the fact that you don't feel that you need something anymore. That's more of a physiological response. So your body tells you when it's hungry by stomach growling, and therefore when the body feels that it's reached a point of satiety, then that will cease. And that's what you want to understand. Also, you see a key term in black here, sarcopenia, which is really muscle mass breaking down or diminishing. It's that accelerated cell turnover that we've looked at previously. And so when you see these wasting diseases or this cachectic, if you recall the word cachexia, appearance, that's what you are witnessing. Wellness concerns are outlined on the next several pages. You do not need me to review that with you because the book explains it all quite well. And as always, you can glance through some of these checklists. When you get to the bottom of page 73, you get into protein deficiency, which is certainly rare, but certainly a genuine concern in particular circumstances. So you definitely want to take the time to familiarize yourself with those circumstances. Many people are aware that there are nutrition supplements in use in clinical settings such as Boost or Ensure, so there's some reference being made to this right here. Definitely something you want to take 2 moments to read, and a very important box on this page is the interaction between drugs and protein. And then, of course, we wouldn't be doing due diligence if we didn't touch on high protein diets, so I have included some questions on your assignment relevant to that section as well. And then it gets into the vegetarianism that so many people are curious about, and the book gives you a nice, simple outline. High protein diets are mentioned again here in the hot topics section, so you definitely want to read that. And it really begins to conclude here, and as always, I encourage you, when you get to the end here, to kind of assess your knowledge or understanding of everything that you have read and heard in this lecture by going through both your nursing assessment outline that gives you a great illustrated example of how to use this information, and of course these bullet points right here in the chapter summary. And if you're walking away able to look at these things and feel comfortable, then you know that you're on the right track. So that being the case, I'm just going to briefly return to the slides and remind you that once again we have to continually think about legumes or beans. So in the carbohydrate chapter, you learned that legumes, which is just a fancy name for all these different types of beans in essence, and you can see some are referred to as pulses, but again, for simplicity's sake, you can call them all beans. You learned that they are plant foods. Therefore, they contain carbohydrate, the body's preferred and primary fuel source, as well as water, vitamins, minerals, even minute amount of fat, and a significant amount of protein, making them a dense source of protein in our diets. You also learned then that they had many health benefits, but what you may not realize is that they are the protein-rich equivalent to meat, which is why you see things like bean burgers, why you see tofu and other soy-based products, because soybeans are actually identical to the proteins in meat. They are obviously very fiber-rich, which you know has numerous health benefits. They are nutrient-dense in all the respects that are outlined here, and unlike animal foods, they do not contain some of the fats that are of concern to our health when consumed in excess. So legumes or beans don't have saturated fats, trans fats, or cholesterol, which we're going to get into in the next chapter. And one of the best parts is that they are extremely inexpensive and certainly environmentally friendly, as you'll learn at a later date. Many animal foods take a toll on the environment in terms of rearing animals. And so when we're thinking about how we can dispel the myth that healthy eating is expensive, one of the first things that should come to mind is beans. Now, not everybody is the most creative in the kitchen, so some people picture a pile of beans and find it unappealing, or some people unfortunately automatically think, oh, I'll get a giant can of baked beans, but you know to read the nutrition facts panel. So at this point, simply by seeing that this is seasoned with bacon and brown sugar, hopefully that's a red flag, right? You know that the high in fiber claim doesn't cancel that out. You know that you want to assess the sodium and the added sugars and look for those which are the least adulterated. And then you can come up with all kinds of creative ways to incorporate more beans into a diet so that you enjoy what you're eating and you get variety. So let's summarize. Protein is a macronutrient. Foods contain mixtures of nutrients. So much like there is no food called carbohydrate, there is no food called protein. Foods contain carbohydrate. foods contain protein. So hopefully moving forward, you'll be able to help people understand that when they're referring to the foods that you see here, that they are referring to packages of mixed nutrients, including water, vitamins, minerals, fats, protein, and even carbohydrate. As always, your questions are welcome.